Welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux. So in the previous tutorial I taught you about the different types of payloads, but I mentioned one thing, that there is one more thing, that is reflective DLL injection. So reflective DLL injection is a technique whereby a stage payload is injected into a compromised host process and it is running in memory. It's never touching the host hard drive. The VNC and the interpreter payloads, they both make use of the reflective DLL injection. You can read more about them from Stephen Fever, that is the creator of reflective DLL injection method. So I won't be getting much into that in deep, because I now have to go and start as to how we are going to actually generate a payload for Metasploit. So now that we have an understanding of what payload is, payload types, and when to use them and how to use them, let's generate some payloads. So generating a payload is not that difficult in Metasploit unless you know exactly what you're doing. So during exploit development, you will most certainly need to generate shellcode to use in your exploit. In Metasploit, payloads can be generated from within the MSF console. So when you use a certain payload, Metasploit adds the generate, pry, and reload commands. Generate will be the primary focus of this section in learning how to use Metasploit. So we'll just go ahead and use the payload. So I'll just type, I'll just get back into my Kali. Let's type use, and I'll just type the payload, and I'll use the Windows one. So I'll just type Windows, and I'll be using the shellbind TCP that I showed you previously. And just make sure that this bind option is this is the underscore, and there are no hyphens over here. I'll hit enter. It has selected the Windows shellbind TCP, where shell over here is the stage, whereas the bind TCP is the stage. Oh, sorry, the bind TCP is the stage, whereas the shell is the stager. So now over here I'll just go ahead and type help to see what all things we have. So you can see I can go ahead and use these commands to communicate with the host. Yep, connect and all of these things. We have these database backend commands such as credentials, which I will be teaching you in the next tutorial. And finally we have the payload commands to check, generate, pry, and reload. So now I would be going ahead and using the generate one. So I'll just since we need to generate a payload, so I'll just type generate space -h. So to generate shellcode without any options, simply execute the generate command. But over here I'm actually trying to show you exactly how we could actually generate a payload with some other understanding. So it would be forced encoding to go ahead and hide it from the antivirus or the AV. We have the list of characters to avoid so that the antivirus does not go ahead and detect us. Name of the encoder module, the output file, and if I just go ahead and type generate, it will just generate a simple without unencoded payload. So I'll just type generate, and as you can see, this is how the payload looks like. You may or you may not be able to understand exactly how it is, because this is just the script to go ahead and avoid or get, you can say, as get false permission from Windows to go ahead and access something from them. The real thing starts over here. That's how it looks like. So after that, of course, the odds of generating shellcode like this without any sort of tweaking are rather low. More often than not, bad characters and specific types of encoders will be depending upon the targeted machine. So this sample payload over here, it contains an almost universal bad character, that is the null byte, which is /x00. So if you look properly into this, you will surely go ahead and find this /x00, these stuff, and that's how the antivirus goes ahead and finds the actual culprit, that is our virus or the Trojan or whatever you want to call. Over here I'll be calling it payload. So granted, some exploits may use or it may allow them to use it, but not many. Let's generate the same shellcode, only this time we will instruct the Metasploit to remove this unwanted byte. So to accomplish this, I will issue the generate command followed by the B switch with accompanying bytes we wish to be disallowed during the generation process. So as you can see, I have this specific term over here, which I will be using B to go ahead and avoid the list of characters. So I'll just type generate -b space, and I'll type in inverted commas /x00, and I'll hit enter. So as you can see, this time there is no /x00, and it's quite a good encoded payload, whereas the last time you can see after the 82 we have /x00, whereas over here we don't have that. You can go ahead and search the whole file, you won't even find anything over there. So looking at this shellcode, it's easy to see compared to the previously generated bind shell. The null bytes have been successfully removed, thus giving us a null byte free payload. So we also see other significant differences as well due to the change we enforced during generation. One difference is the shellcode's total byte size. In our previous iteration, the size was 341 bytes. This new shellcode, however, is 27 bytes. So that's quite much of a difference that created with the help of null bytes payload. So I'll just go ahead and generate this, and this is normal one with the 341 bytes, and if I go and type this is the normal one with our 27 bytes. So it's quite good. So yeah, so during the generation, null bytes original intent or usefulness in code, it needed to be replaced or encoded in order to ensure once in memory our bind shell remains functional and it is not thrown out by the antivirus. Another significant change is added to the use of encoder. By default, Metasploit will select the best encoder to accomplish the task in hand. The encoder is responsible for removing unwanted characters, amongst other things, entered when it was used with the -b switch like I used. So I'll discuss the encoders in great detail later on. So while specifying bad characters, the framework will use the best encoder for the job. And the best over here is the into 32-bit, that's x86/Shikata Ganai. That, and you might be wondering that if I have heard about that before. Now I'll show you exactly where we have seen it. Let's select social engineering, and I'll just go and use some random stuff. And these two, and over here as you can see we have the Shikata Ganai. So this is where we have heard it previously. So yeah, coming back to our point, the into 86 Shikata Nagai encoder, it was used only when the null byte was restricted during the code generation. So if I add a few more bad characters, a different encoder may be used to accomplish the same task. So let's add several more bytes to the list and see what happens. So I'll just type generate b/ and over here I'll just go ahead and change some of the things, such as /x44/x67/x66/x, let's say. We'll also use some characters, and /x01/x44/x67, and what else, let's say xa1, let's say for example, xa2/xa3/x75/x4b. Perfect. So we'll be using these, and we will use a different encoder. So let's see what happens. All of these unwanted bytes were removed. Perfect. But the size over here is 350 bytes, whereas over here it was 355, and over here it was 328. So what is the difference? So we see a different encoder was used in order to successfully remove our unwanted bytes. Shikata Ganai was probably incapable of coding our payload using our restricted byte list, and FNSTENVMove on the other hand was able to accomplish the same thing. And as you can see, we have the FNSTENVMove which had encoded this. So having the ability to generate shellcode without use of certain characters is one of the greatest features offered by this framework. This doesn't mean it's limitless. If too many restricted bytes are given, no encoder may be set up for the task, at which the Metasploit will display something such as the payload generation has failed. Let's go ahead and try something like that. I'll use the same code with a bit of modification. 44, 67, 66, XFA, X01, XEO, 67 until 4xb, and let me just go ahead and change this a bit. I'll use XFF/X0A/ let's say X0B/ X01, let's say X01. After that, let's say XCC/6E/X1E, and then we have /X2E. we have, let's say, /X26, and let's see what happens right now. As you can see, no encoders encoded the buffer successfully. So it's like removing too many letters from the alphabet and asking someone to write a full sentence. Sometimes it just can be done, and if you have seen that in movies that they can just go and type something and hack into something, that's how exactly this is. It does not work in reality, at least not. you have to just sit inside in front of the computer and wait for something to happen. That's not going to happen. You have to actually try for that to happen. So using an encoder during a payload generation is not that difficult, but at the same time it's not that easy as well. So as mentioned previously, the framework will choose the best encoder possible when generating our payload. However, there are times when one needs to use a specific type, regardless of what Metasploit thinks. Imagine an exploit that will successfully execute a command, provided it contains only non-alphanumeric characters. The Shikata-Nagai encoder would not be appropriate in this case, as it uses pretty much every characters available to encode. So looking at the encoder list, I'll go ahead and show you something different, but that would be it for this tutorial. And in the next tutorial, I'll be going ahead and I'll be ending this payload tutorial by showing you how we could actually go ahead and use some different encoders to redo our bind shell payloads.